Myself, Jijendra. Subject name is Engineering Tribology. My topic is about an examination of in process tool wear estimation in milling using a cutting force model. Introduction. The research paper develops into the topic of in process to wear estimation in milling using a cutting force model. Through detailed examination, the study aims to uncover the effectiveness and accuracy of this method in predicting tool wear during milling operation. By analyzing the cutting force involved, this research contributes to advancement of tool wear estimation techniques benefiting the manufacturing industries. Is nothing but milling cutting force must be gives the benefits of manufacturing industry. Most of the milling operations is done in manufacturing industries only. Methodology. Developing a cutting force model for tool wear estimation. To accurately estimate tool wear in milling, a methodology based on a cutting force model is proposed. This involves analyzing the cutting forces during milling operation and correlating them the tool wear measurements. By developing this model, we aim to provide a reliable and efficient tool wear estimation technique that can enhance machining process and prolong tool life. And nothing but the durability of the tool must lives long life. Experimental setup. In order to examine in process tool wear estimation in milling, an experimental setup is crucial. This includes selecting appropriate cutting parameters, using a dynamometer to measure the cutting force, and implementing a cutting force model. The experimental setup allows researchers to collect data and analyze the relationship between cutting force and tool wear, providing valuable insights for optimizing milling process and prolonging tool life. Is nothing but the experimental setup how the milling of a cutting tool operation should be done. There is a sequence of a procedure. uh, First, the wear estimation of milling. The setup of the tool should not be where it is the first step. What um, the dynamometer is used to measure the cutting force, and it and the cutting milling cutting force should resist the wear. Result and analysis. After conducting the milling experiment and analyzing the collected data, several key findings have emerged. The cutting force model accurately predicts tool wear based on the measured cutting forces. By monitoring these forces during the milling process, operators can proactively assess tool wear and schedule maintenance, ultimately optimizing productive and extending tool life. The result also demonstrate the effectiveness of the experimental setup is enabling accurate tool wear estimation and providing valuable insights for process improvement. This is the after the experiment, the result and analysis should be done. The collective data of the experiment, it gives the important role to analyze the cutting force model. Discussion. Analysis of the tool wear estimation model and future recommendation. The analysis of cutting force model for tool wear estimation in milling shows promising result in accurately predicting tools were based on measured cutting force. This opens up possibilities for proactive tool maintenance and process optimization. However, further research is required to validate the model under different milling conditions and explore its applicability to other machining processes. Additionally, integrating real-time monitoring and automated maintenance scheduling can enhance productive and cost effectiveness in industries. In this slide, we can see the design of the tool. It is a flat line icons design tools. This is the icons of the tools which we are used in a milling machine to resist the wear. Conclusion. In conclusion, the cutting force model for tool wear estimation in milling has demonstrated its potential for proactive tools maintenance and process optimization. However, further research is needed to validate its applicability in various milling conditions and other machining process. Integrating real-time monitoring and automated maintenance scheduling can significantly enhance productivity and cost effectiveness in industrial setting. Conclusion. We can see the cutting force model for a tool estimation milling has demonstrated a potential proactive to the tool maintenance and the cost effectiveness in industry is most of the important thing to get a good product in a industry. Good work piece of a milling cutting tool. Future research directions. While cutting force model has shown promise in tool wear estimation, future research should focus on validating its applicability in different milling conditions and exploring its potential in other machining process. Additionally, integrating real-time monitoring system and automated maintenance scheduling can further enhance productivity and cost effectiveness in industry setting. By continuing to investigate these areas, we can continue to optimize tool maintenance and improve overall machining process. In this slide we have seen the introduction and methodology in which the cutting force model for a tool estimation should be during the milling operations and correlating them to a tool wear measurement. The tool wear estimation technique must be enhance the machining process and pro tool long life. Experimental setup. This is the important for a milling cutting force operation. The experimental setups. After the experimentation, we can go to the analyzing and result. In this we have seen the cutting force model accurately predicts to wear based on the measure cutting force. This the result also demonstrate the effectiveness of the experiment setup. The experiment setup is the important thing where the where the cutting or where the milling operation should be done and get a output in a good manner, and the cost effectiveness in a industry should be low because the bulk of operations is done in the industries, so they need to uh, first first do the experimental setup, then they need to proceed for a output of a workpiece. Discussion. In this we have seen the design of a tools which we are used in the operations. These are some of the designs of a line tools. um, Conclusion. In this conclusion, integrating real-time monitoring and automated maintenance scheduling can significant enhance productive and cost effectiveness in industrial setting. Tribology is nothing but it deals with the lubrication, wear, and friction. It The tribology is nothing but it deals with friction, lubrication, and wear. Friction, where the heat is generated, then the friction will produce lubrication. Lubrication gives the motion for a tools, or for a tool or in a engine, IC engine parts, where is the main piece, main thing, the material should not resist to the wear. If it happens, the life of the material will be decreased. Future research, as we have gone through this, the future research, it is also gives the effectiveness in the industrial setting. uh, Thank you.